Large language models write correct code for isolated problems, but remain far weaker at autonomous machine learning development, where an agent must revise data pipelines, models, and validation over hours of feedback, and on most competitions still finishes below strong human competitors. We introduced TraceML, which pairs human and agent work on the same competitions under one version level schema. This dataset includes 4,465 human Kaggle trajectories across 134 competitions, 7 of which are also worked by 2 agent scaffolds, giving 430 paired human and 207 agent trajectories. Each agent scaffold instead collapses into a narrow loop. Codex spends its steps reweighting ensembles and tuning submissions. MLEvolve mutates its model in place, and neither pivots at the human rate nor reopens abandoned work. A short planning prompt distilled from human practice moves the behaviors it names toward the human profile and lifts scores, but the effort profile stays agent-shaped. Instruction closes only the part of the gap that reduces to instructions. Outcome-based benchmarks record this gap but not its cause, because they grade the final submission and discard the development process behind it. TraceML provides insight into the process of development itself, which allows for a deeper understanding of where agents fall short. This empirical analysis provides a clear comparison between human and agent planning in machine learning development, identifying both the strengths and limitations of each approach. We release the corpus, the schema, the labelers, and the extraction pipeline at the provided link. This dataset enables further research into human-agent collaboration in machine learning development.